a few practice problems with histograms. So we need to create a histogram to represent the class average for an 8th grade math class. And also reminds us not to forget to title the histogram and give my x and y appropriately scaled and equal intervals. We want to make sure that they are equal intervals and also appropriate for the numbers that we're working with. So here are my averages, and they are already in least to greatest order, which is really nice. And so these just need to be, broken up into intervals of equal amounts in between them. So a lot of times we break things up into those tens, the 40s, the 50s, the 60s, the 70s, the 80s, the 90s, and so on. So let's stick with that general principle, and we will do an age band of, 40 to 49, 50 to 59, 60 to 69, 70 to 79, 80 to 89, 90 to 99. And in this case, luckily there's not a 100, but if there was, we would do 100 to 109. If we had any decimals or anything like that, we would need to make sure that our intervals included those numbers as well. So we want to make sure that our numbers don't overlap, but they also include all the values that we have. So here, between 40 and 49, we have 1 value. Between 50 and 59, we have 0 values. Between 60 and 69, we have 2 values. Between 70 and 79, we have 5 values. Between 80 and 89, we have 9 values. And between 90 and 99, we have 5 values. Okay, so I have not a ton of values here that I need to include in my class averages on my y-axis, but I do have my intervals here for my x-axis, so let's go ahead and put those in. So I have 40 to 49, I have 50 to 59, I have 60 to 69, 70 to 79, 80 to 89, and 90 to 99. And since I have a maximum number of non-frequencies in any interval, I'm going to start with 0 down here, and I'm just going to do 2, 4, 6, 8, 10, and 12 for my y values. Now, I do need to remember to put my title in, and so this we can just call 8th grade class averages, math class averages, however you wanted to do it. I'm just going to call it class averages. Okay. You could be more specific if you'd like to. There's no problem with that. Alright, so let's go ahead and create our histogram. So I have one interval, one student who had a 40 to a 49, so I'm going to create my bar here. And 1 is between 0 and 2, so I'm going to half that, and I'm going to build that. And then I can shade it in. If you would like to, you can shade that in. Okay. Then 50 to 59 range, there is no 1. So I'm going to skip that one, and I'm going to go to 60 to 69, and there are 2 in this interval, so I'm going to go up to the 2 line, and I'm going to make my bar, and if you would like to color that in, you can as well. Alright, 70 to 79, there are 5, so I need to go up between the 4 and the 6, and notice that I am touching the bar here, but not overlapping it, okay? And you want these to be as equal width as you can do. And then 80 to 89, there are 9, so I'm going to take that and go all the way up to halfway between 8 and 10. And I'm going to make my bar, color it in. And then my last one has an interval of 5, so again between 4 and 6, and bring that down, and color that in. Okay, so here is my histogram for the information. So notice that I have my intervals, and they're evenly spread out. I've got an appropriately scaled y-axis for the number of frequency, or the frequency of those grades. I've got a title, and then I represent each of those grades here in these values. Okay, so that's the histogram here. Now, the second question here asks us to describe the shape of the distribution of the class average. So notice that my data, I have this 1 value out here, but then I have kind of my peak of my value over here. So the data looks like it's skewed left. And it's a possibility that might be an outlier. It doesn't look like it. You could do the calculation to find out for sure if you were asked about outliers. But since it's just asking for the shape of the distribution, I'm going to say that it's skewed left. All right, now the other question says, how would you interpret this information? What does that mean? So does that mean that most of the students are doing fairly well and have that data of 70 or above on their class average with just a few outliers? Or is that, how would you interpret that? And that, again, it's going to be your personal opinion. So that question will depend on how you would view that. Do you view that as, the students are, if you want to take that into the situation that, okay, well, the students are seeming to understand the material, and they're doing average or above, however you want to interpret that. But that's kind of your interpretation there, your opinion question. As long as you justify your answer and you can show why you chose that or why you said that, that's perfectly acceptable. Okay. Now, number 3 asks us to use the values from the first question to compare the estimated mean and the actual mean of class average. We're supposed to use the values and the histogram. So let's do an estimated mean first with the histogram values. Okay, so we will start with, let's do our estimation. Okay, so we need to go through each interval. So I'm going to do, we have 2, 3, 4, 5, 6 intervals. So I'm going to line them up, 2, 3, 4, 5, and 6. And I need to find the midpoint of each of these intervals. So between 40 and 49, the midpoint would be 40 plus 49 divided by 2. So it's going to be a midpoint of 44.5. Okay. And there is a frequency of 1 here. So when I multiply that, I get 44.5. Okay, the second interval has a midpoint of 54.5. Okay, because I'm just going up by tens here. So 54.5, and there is 0 for my frequency. There's none in that bracket. Okay, 3, 60 to 69 has a midpoint of 64.5, and there are 2 students who fall into that bracket. So when I multiply that 64.5 by 2, I get 129. Right, then in the fourth interval, I have 70 to 79, so 74.5 is my midpoint, and there are 5 students in that interval. So 74.5 times 5 is 372.5. In the fifth, 80 to 89, that's a midpoint 84.5, and there were 9 students in that interval, so we're going to multiply that by 9, and we get a value of 760.5. And then in the sixth one, we have 5 as well, so my midpoint is 94.5, and there are 5, and we multiply that, we get 472.5. And then we need to average that together, so 44.5 plus 0 plus 129 plus 372.5 plus 760.5 plus 472.5, all divided by the number of the frequencies here. So we have 1, 0, 2, 5, 9, and 5. So let's simplify here a little bit. Let me add these values together. So 44.5, 0, 129, 372.5, 760.5, 472.5. And we have a value of 1779 for the sum of those. And then we have 1 plus 0 plus 2 plus 5 plus 9 plus 5. So a total of 22 students here. So our estimated average, when we divide that, is a value of 80.86. Okay. Now, then we are also asked to find the actual mean, and this is not often that we actually get this opportunity to compare them, because most of the time your histogram doesn't also include the actual values that you've been given. Most of the time you're either given a histogram or you're given a set of values. So this time we actually have the opportunity to compare the two, an estimate versus the actual average. So let's do that. The actual average, we have the values. So 44 plus 64 plus 68, and I'm going to type these in to my calculator as I go, plus 70 plus 70 plus 72. So add those. 75, 77, 81. And then we're going to keep adding 82 plus 82 plus 82. And I'm going to keep adding 83 plus 84 plus 87. Okay, and then 88, 89, and 91. And then 93, 95, 98, and 99. And we get a value here of 1774. So there's 1774 is the sum. And we again have 22 values. Just to double check, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 students. So we're going to be dividing by 22. So when I divide those, I get 80.64. So I have an estimated mean of 80.86 and an actual mean of 80.64. So this was actually a very, very close estimate to the actual mean. So in comparison, however you want to compare that, again, it's your opinion how lengthy or how focused you get your answer. But basically, I just want to make sure that you understand that the estimated mean and the actual mean are very close together. And they are within a half a point of each other. So they are very close. So this is actually a very good estimate to the actual